The low voltage regulators are found on pull-out schematic 10. Now the schematic I have is pretty cluttered, and I understand they're not going to redraw this for the next edition of the manual. So if you have this cluttered schematic, I would suggest that you take a colored pencil and kind of divide the circuits a little bit. Now right at the top is 130 volts, and that is the pre-regulated supply, and it's not re-regulated here. Now the next one down is the 50 volt supply. It supplies about 500 to 600 mils. And along the right margin there, if you'll start just below where it says lights common, draw your colored line to the left, just right straight across. Where it reaches the left margin, it should be just above where it says plus 17 volts. Now you're going to cross a line or two there, but that can't be helped. All right, the next supply down below is a plus 15 volt. It provides about 3 amps. And just below where it says plus 15 cents, start your colored line off to the left, take it up above where it says Q1489B, down below CR 1439, and up above plus 17 volts. You kind of have a curved line there, but it separates the plus 15 supply from the minus 15 supply, which is next. It also supplies about 3 amps. Now draw your next line in between minus 15 volt cents and minus 50 volts off to the left. And I'll wander around over Q1526. You're going to have to intercept that line that goes to plus 17 volts. To the left, diagonal down below CR 1469, and down below that emitter tail, which ties to a minus 50 volts. The next one then is the minus 50 volt supply. It provides between 500 and 600 mils. Start your line about a half inch below the minus 50 volt cents. To the left, then up a little bit over the top of Q1576 A and B, and right straight to the left, and just above where it says plus 7 volts. Now everything that's left down below is the plus 5 volt supply and the graticule illumination circuit. Now it consists of Q1546 and Q1555, so if you'll draw a vertical line to the right of that transistor, then everything to the right of it would be the plus 5 volt supply. And that supply, by the way, provides 3 amps. Well, let's start with the plus 50 volt supply. It uses the plus 54 pre-regulated supply as its source. Now off to the right there we have the plus 50 volt cents. Now that's a point on the motherboard which we want to regulate. The load is tied into that point. The filter is located there. Now that's the point we want to hold constant at 50 volts. Now if in regulating that point constant it's necessary for us to bring the output from this circuit above 50 volts, why, so be it. We're really not interested in that. We want to keep the 50 volts at the load constant, and that's where we pick off this 50 volt cents. All right, it comes off to the left through error divider composed of R1413 and R1412. C1413 is just a speed-up cap for that divider. It drives into a comparator composed of a dual transistor, Q1409A and B, the dual transistor, so that the two sides' temperature compensate one another. Now the base of the A side is referenced to ground. Now the bottom of the error divider is tied to minus 50 volt cents. My manual shows that minus 15 volts. The minus 50 volt regulator is the reference for all of the other regulators, it in turn is referenced to a 9-volt Zener. We'll see that later. All right, any change in the 50-volt sense, therefore, is felt at the base of Q1409B. That error signal, amplified but not inverted, appears across collector load resistor R1404 to drive into the base of voltage amplifier Q1415. There we do have gain and inversion to drive into the base of current amplifier Q1425, which in turn drives series regulator Q1428. Well, let's see if we can make the thing work. Let's assume an increased current requirement on the 50-volt supply. The 50-volt sense goes in a negative direction a little bit. That drops the base of Q1409B. The collector of the A side goes down. Now that biases Q1415 to less conduction. Its collector pulls up, which biases Q1425 to greater conduction, which in turn biases the series regulator Q1428 to greater conduction. And it satisfies the needs for the increased current requirement in the load. Now, since this entire regulator is an operational amplifier, then as we know, it'll maintain the 50-volt sense constant under varying loads. Q1418 provides overload protection. Just to the right of it, R1428 is the overload sense resistor. Now, if the current begins to get too high because of a short or overload in the supply somewhere, and we increase the current through R1428, the voltage drop across it gets large enough to turn on Q1418. Its collector then would pull up on the base of Q1415. Its collector would come down, bias Q1425 to less conduction, which in turn would bias Q1428 to less conduction. So-called fold-back protective circuit, which means that as the load current increases in overload, the current delivered from the regulator decreases. Now, the circuit that accomplishes the fold-back feature is a divider, R1422, R1420, and R1421. Now, those two resistors have a Thevenin equivalent of 28.2K to about 33 volts. Now, the emitter of Q1418, you'll notice, is tied to 54 volts. So we have electrons flowing up through that Thevenin equivalent resistor to the base of Q1418. Now, as the overload current causes a greater voltage drop across R1428, the sense resistor, and it turns on Q1418, and as we discussed a moment ago, biases the series regulator to less conduction. Well, with less current supplied and more required, then the plus 50 volt output would go in a negative direction. Now, through this Thevenin equivalent resistor, it would then pull down even harder on the base of Q1418. Turning that transistor on harder then would be dictated by the current through R1428. The net result is fold back, in which less current is delivered from the regulator as the current requirement increases. Now remember, this occurs only with a short in the supply. One can short the plus 50 volt supply or any of these supplies directly to ground without damage. Now let's pick up some of the odds and ends here. Right between the plus 50 volt output and the 50 volt sense is R1429. Now that keeps the regulator from going wild if the plus 50 volt sense is disconnected. CR1429 keeps the plus 50 volt bus from going below ground if it's shorted to one of the minus supplies. Now that protects the electrolytic capacitors over on the motherboard from reverse biasing. Over there by voltage amplifier Q1415, the RC time constant R1416 and C1416 slows down the reaction of this regulator to keep it from oscillating. Now over by the error comparator, there's a network composed of VR1401, R1401, and CR1402. Now that diode is reverse biased under normal operation. However, if the plus 5-volt supply should short to one of the positive supplies, then we lift through the zener through CR1402. Off to the right there, turn on Q1415 harder. Its collector pulls down, shutting off the series regulator. Now, since the plus 5-volt supply uses the plus 50 as a collector load for the comparator, then that would shut down the plus 5-volt supply. In between the bases of that dual transistor is CR1410. Now that's to protect the base emitter junction of Q1409. Now the speed-up capacitor C1413 has a 25-volt drop across it. You see the base of Q1409B would be at 0 volts. The right side is tied to plus 50 volts. Now if one were to suddenly short that plus 50 volt sense to ground, we would get a 25 volt negative going step coupled across that capacitor into the base of Q1409, driving it way below its emitter and damage that base emitter junction. Well, CR1410 catches that base. Notice that the base of Q1409A is returned through an 18K to ground, while we're providing a similar base load to that on the B side. Seems like that value should be 20K instead of 18, doesn't it? All right, I guess that covers the plus 50 volt regulator. Let's drop down to the plus 15 volt supply. Remember that delivers about 3 amps. Let's start with a plus 15 volt sense. The error divider composed of R1441 and R1440. C1441 is the speed-up cap. Another dual transistor as an error comparator. The base of Q1436A is tied to ground for comparison. Now we do have polarity reversal in this case taken off across collector load resistor R1432. That in turn drives into current amplifier Q1451, which in turn drives current amplifier Q1455, which in turn drives the series regulator Q1458. Now the normal configuration there would be one in which the collector of Q1451 would go to the same supply as the two transistors to the right. However, there just wasn't room for it here. If you start with the plus 15 volt output there, you go up 3 junctions through those 3 transistors. Well, if you tied the collector to plus 17 volts, then you just wouldn't have enough collector supply. Now the collector supply for Q1436B is actually plus 50 volts clamped there by CR1431. R1431 to 130 volts is just a pull-up. Now the overload protection circuit is composed of Q1445A and B, another dual transistor for thermal compensation. The base of the A side is set by that divider at 16.4 volts. Now quiescently, the A side is off, the B side is on. Now the overload sense resistor is R1457. As the current increases in overload to the point that we get enough voltage drop across that resistor to turn off Q1445B, that in turn turns on Q1445A. The collector current then turns on CR1445, turns off CR1431. That pulls that point down, pulling down on the base of Q1451, biasing that to less conduction, which in turn, through the other current amplifier, biases the series regulator transistor Q1458 to less conduction. R1448 and R1449 form the divider that provides the fold-back feature. CR1459 prevents that plus 15 volt bus from going below ground and damaging the electrolytic over on the motherboard if it gets shorted to a negative supply. Over there off the collector of Q1436B, R1436 and C1436 slows down the reaction of the regulator to keep it from oscillating. And CR1439 protects the base emitter junction of Q1436B in the same manner as the plus 50 supply. Well, let's drop down now to the minus 15 volt supply. Now the 15 volt sense drives directly into the base of Q1466B.